Pi is 3.14159265, but you came here for Pocket Roni, so please stay tuned.
Okay, we're going to be doing proofs of right triangles. So in my ideal world, these two triangles are congruent, so just pretend like that they look exactly the same, and they're both right triangles. So in a right triangle, we already know that these angles are congruent, because if this is a 90-degree angle and this is a 90-degree angle, then we already know that they are congruent. So we already have congruent angles right here. In our bag of tools, so far we've had side, 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 angle, angle, and angle, angle, side. You need to know 3 pieces of information in order to prove two triangles congruent. Since in right triangles we already know one piece of information is congruent, you only have to have 2 more pieces of information only in right triangles. Okay? Let's just say, remember in right triangles, these are both legs. The side on each side of 90 degrees is called a leg. The side opposite the right angle is the hypotenuse. So let's just say that this leg was congruent to this leg. And let's just do the legs for right now. That leg is congruent to this leg, and they're different. So if these were to be regular triangles, see how that would be side, angle, side? So this is the same as side, angle, side. But we already know that these angles are congruent. So in right triangles, if we can just prove that each leg is congruent, then we can call that leg, leg. Okay? Leg, leg, LL. That's similar to side, angle, side. Alright, let's also, if we knew these 2 legs, can we determine the hypotenuse? Yes, because if I knew this leg and this leg, I can use Pythagorean theorem to determine the hypotenuse. So if you know 2 legs or 2 of the sides in a right triangle, then you can determine the 3rd side of a right triangle because of Pythagorean theorem. So also, in place of side, 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 if you just know 2 legs, leg, leg, then you can also say that they're congruent. So, leg, leg. Alright, let's say that we had, if you didn't have those legs congruent, but you were told that this leg and this leg are congruent, and then you were told that these angles are congruent. You already know the 90 degree are congruent, and then you're told that these legs are congruent. Now you're told that this angle is congruent. This would be the same as angle, side, angle. Okay? Angle, side, angle. We already know this, so we had to know these 2 pieces of information. This is a leg, and this is another angle. So we call that LA. Another leg and another angle. So having known another leg and another angle, that puts it towards angle, side, angle with the 90 degrees. We can instead replace that with LA. Now, just know these 2 letter ones are only for right triangles. Only. So be sure and make this note, right triangle. So that means leg, angle. Also, let's just say that I didn't know that that leg was congruent, but instead that it was this leg over here that was congruent. Then that would be angle, angle, side, because the side is not in between the 2 angles. Angle, angle, side. I still know a leg and I still know an angle, so I can still call that LA in replace of angle, angle, side. Okay, so one other thing we can have is what if we knew the hypotenuse? So I'm going to take that away, change that. if we knew the hypotenuse, the two hypotenuses were congruent, and then we knew another angle, still go back to this angle right here, that is still the same as angle, angle, side. But this side that we know now is called the hypotenuse, so that's hypotenuse and angle. So if we know hypotenuse and an angle, to where the side is not in between the two angles, that's similar to AAS. So hypotenuse angle would fall into this category. And then there's one more that we can do, the hypotenuse leg. So if we knew that the hypotenuses were congruent, and we know that either leg, it doesn't matter which leg, we knew that either leg was congruent. If you knew the hypotenuse and you knew this leg, can you figure out this other leg? Yes, from Pythagorean theorem. So therefore, if we knew a hypotenuse and a leg, we can figure out the other one, and we call that HL. And since we can figure out this other one, that would be the same as side, side, side. That would be called hypotenuse leg. So if this seems confusing to you, if you boil it down, you just need to have two pieces of information for a right triangle. You need to know if you can prove two legs are congruent, then you can prove that both triangles are congruent. If you can prove that a hypotenuse and a leg are congruent, then you can prove both triangles are congruent. If you can prove that a leg and one angle other than the 90-degree angle is congruent, then you can prove the two triangles congruent. If you can prove the hypotenuse and an angle other than the right angle are congruent, then you can prove the two triangles are congruent. Okay? Again, leg, leg, hypotenuse leg, leg angle, an angle other than the right angle, and hypotenuse angle, angle other than the right angle. If you can get these two pieces of information on a right triangle, then you can prove the two triangles congruent. Alright, let's see an example of this on 26A. On the front side, the bottom picture. I am not going to prove this the way that the book does, so I'm going to do it my own way, not the solutions in the back. So we have this triangle, and we are given that triangle HJM is equilateral. What do we know about equilateral triangles? Equilateral triangles means that all sides are congruent. So it means this side is congruent to that side, and it would also be congruent to JM. Okay? Since JM, that whole side is not completely in one of my triangles, I'm not going to mark it. I'm just going to mark that these two sides are congruent. Just so you know, the way the book does it, in an equilateral triangle, also all of the angles are congruent. Equilateral is the same as equiangular, and so that means that these angles are congruent. But this angle is shared by both triangles, so you don't want to use that one. So the book uses the angles. I'm going to use the sides, because that's what most people are going to think of in an equilateral triangle. They're going to remember that the sides are congruent. So I know that this side is congruent to this side. What else am I given? That HK is perpendicular to JM. As soon as you see that, in my opinion, mark your triangle, because you see that that's perpendicular, you have a right triangle. I only need to have two pieces of information other than my right angles to prove the two triangles are congruent. So I already know that these angles are congruent. Then the other piece of information I know is that HK is shared by both triangles, so those are congruent to each other from reflexive property. Looking at one triangle, this is a leg, this is my hypotenuse. So I can prove that these are congruent by hypotenuse leg. Hypotenuse leg. This is my hypotenuse, this is my leg. I have to have two pieces of information other than the right angle. So hypotenuse leg. So now you have to put all of this into your statements and reasons. So you have to enter everything into a court of evidence, and you have to be pretty detailed and specific about this. So the first thing I'm going to start with is my givens. So the first thing I will say is that triangle HJM is equilateral. Why? How do I know that? Because it's given. Okay, number 2, I was told that HK is perpendicular to JM. How did I know that? It was given. Now, from my given statements, what did I know? From the fact that my triangle is equilateral, that told me that JH was congruent to MH. So I'm going to make that statement. JH is congruent to MH. Remember, if you say J to H, you need to say M to H because J and M correspond. Why? I would just put, there's so many different things you can put here. I would just put definition of equilateral triangle. So that is a statement for my hypotenuse. That was my hypotenuse. I have to get all of my information here before I can say the two triangles are congruent by HL. Okay, the next statement. When I found out that these two lines are perpendicular, what do perpendicular lines form? They form right angles. I need to make the statement and put into evidence that I am dealing with right triangles. Because only when I'm dealing with the right triangles can I say that the two triangles are congruent by only two pieces of information. If I never say that these are right triangles in my statements, then I am leaving out some evidence. So I have to put in order a logical order of evidence. Now that I know that these two lines are perpendicular, I have to make the statement that these are right angles. Okay, so I can say angle HKM is a right angle. Oh. Why is that? Definition of perpendicular lines. Because in my axiom sheet it says when two lines intersect and are perpendicular, they form a right angle. So definition of perpendicular. Okay, that was a statement for one of my angles. Now I'm going to make the statement for the other one. Remember, if I say HKM, then I need to say HKJ. So angle HKJ is a right angle. Why? Definition of perpendicular lines. So now I have stated that these two are right angles. So if you want to make the statement that the two angles are congruent, that's okay. And you can write in the reasons that, right angles are congruent. If you don't have that, that's okay too, because the fact that you state that there are right angles here shows that you have right triangles and you only need two pieces of information. So we have a hypotenuse, but now we need to have our leg. So that's our reflexive to say HK is congruent to HK. Why? The reflexive property. That was my leg. Now I have my information for my hypotenuse and my leg, and in my statements, there it is listed that I have some right angles to show it's a right triangle, which means I can prove it using HL. Now I'm ready to make the statement that triangle HJK is congruent to triangle HMK. Why? Hypotenuse leg postulate. Okay, I am on the front side of 26D, the very top picture. And we have this triangle here, TPSQ. The given, I don't know if your book has a typo, but mine does. The given says line segment OP, that should read line segment QP, is perpendicular to line segment ST. So if your book doesn't say QP, it needs to say QP. Then we're also given that P is the midpoint of ST. We are trying to prove that SQ is congruent to TQ. Mine says TO. If yours says TO, correct it so it says TQ. Alright, notice we are not trying to prove two triangles congruent, but we do have to prove two triangles congruent before we can write what we are really trying to prove. But our end goal is to prove that line segments are congruent. So let's go back to the givens and mark our triangle. QP is perpendicular to SP. Perpendicular lines form right angles. So mark in your picture that these are right angles. The fact that we have right triangles means we only need to have two pieces of information to prove the two triangles congruent. Now we know P is the midpoint of ST, which means that line is congruent to that line. Now what else do we know in the picture? This line is shared by both triangles from reflexive property. This is the leg, this is the leg. The legs are on each side of the right angle. This is the hypotenuse. The hypotenuse is across from the right angle. So now I see I can prove the two triangles congruent by leg, leg. Now I just need to make sure and get all of my statements, everything put into evidence in a good order. Okay, I'm always going to start with the givens. So, given that QP is perpendicular to ST, given, then we are told that P is the midpoint of ST, that's given. Now, from the information we were given, what did we learn? Because QP was perpendicular to ST, it means we created right angles. So we should make that note so that in our evidence, we know we have right angles and we are dealing with right triangles, which means we only have to have two other pieces of evidence. So we can make the statement that QPS, angle QPS, and I'm just going to put them together, and angle QPT, are right angles. Why? Because of definition of perpendicular lines. Okay, from there we know that we have right triangles. In your book, they make a note that you have right triangles. They're not consistent about that. They don't do that for every proof. As long as you have down that you have right angles in your triangle, that should be sufficient. Now, what else did we know from the given? The fact that we were told P is the midpoint of ST, we now know that TP is congruent to SP. So we can say TP is congruent to SP. Why do we know that? Definition of midpoint. So that was one of our legs. We made the statement of that. Now we need to make the statement of the other leg. PQ is congruent to PQ. Why? That is the reflexive property. So that was one of our other legs. And now that we have all of our information in, and we have the information that we are dealing with right triangles, we can now say that the two triangles are congruent. So we can say triangle QPS is congruent to triangle QPT. I'm saying them in the right order. Why? Because of leg, leg. That wasn't what we were trying to prove though. But you have to prove the triangle's congruent before you can use CPC TRC. Now that we know the two triangles are congruent, we now know that every other parts of the triangle are congruent. So we now know the hypotenuses are congruent. So we can say SQ is congruent to TQ. Why? Because of CPC TRC. Remember that is corresponding parts of congruent triangles are congruent. Once you prove the triangle's congruent, all their other parts are congruent. Okay, if you're in my class, we are looking at a problem from a worksheet that is labeled right triangles. If you are watching this like the week of this assignment, you actually will not get the worksheet until next week. But either way, this is just another example from a worksheet, not from the Matthew C. book, of right triangle proofs. Alright, we are given this picture, and then we are told that ST is congruent to VU. So we already have marked ST is congruent to VU. From the picture, we are already given that these are right angles. We don't have to be told that any lines are perpendicular or that we have a rectangle. The fact that it's labeled in the picture, that is your given information. So therefore you can say, okay, I'm dealing with right triangles. I only need to have two other pieces of information. So the fact that I already know these legs, this is a leg, then I know that this line is shared by both triangles. So by the reflexive property, that is congruent. This line is across from the 90 degrees, so therefore that is the hypotenuse. Just be careful of that. The side across from your 90 degrees is the hypotenuse. So now we know a hypotenuse and a leg, so we know we can prove this by HL, hypotenuse leg. We are asked to prove that one angle is congruent to another angle, but remember we have to prove the two triangles congruent before we can use CPC TRC. On these worksheets and they're filling the blanks, they cut everything a lot shorter. They do not even make the statement that these are right angles. They already go through the assumption that that's entered into evidence. In my opinion, it's actually better to go ahead and write in your statements that angle TSU and TSV and TUV are actually right angles. If you actually go through and make those statements, you can never go wrong. You can never go wrong by entering too much evidence over here into your statements. There we go. That looks more like a V, not a U. So, starting out with our statements, we'll just start with our givens. So, ST is congruent to line segment VU. How did we know that? It was given. That right there is a leg, so that's a leg. Again, if you feel better saying TSV and TUV are right angles and putting given, then that is okay. They don't put that down here, so it's up to you. Okay, so then the other thing that we can make the statement is that TV is congruent to TV from the reflexive property. That was a hypotenuse. Now we have the two statements, a hypotenuse and a leg, and we know we have right triangles, so we only have to have two statements. So we can now make the statement that one triangle, TSV, is congruent to the other triangle, triangle TUV. Why? Because of HL. But that was not our final goal. Our final goal was to actually prove that angle SVT was congruent to angle UTV. How do we know that? CPC TRC. Corresponding parts of congruent triangles are congruent. Once you prove the two triangles congruent, all of their parts are congruent.